In this lesson, we are going to go over equations that are written in quadratic form. My little icon for this one is a duck. There's that saying, if it walks like a duck and talks like a duck, then it must be a duck. Well, we're going to see equations that look like quadratics that we can kind of turn into quadratics and apply principles of quadratics. Okay, so we're looking for similarities there, but they won't exactly be quadratics. So our goal today is to apply our knowledge of solving quadratics to solving equations in quadratic form. Okay, so let's review quadratic equations. Quadratic equations are written in the form of ax squared plus bx plus c equals 0, where a is the coefficient of x squared, b is the coefficient of x, and c is the constant. Notice something here, that with our powers, either you can think of it as 2 divided by 2 is 1, or 1 times 2 is 2. So this is going to give us a little bit of a hint into our quadratic form, okay? So kind of how I've written it is we have a times something raised to an exponent plus b times something raised to our exponent divided by 2. So for instance, if this exponent is 4, this exponent would be 2. Or if this exponent is 6, this would be 3 plus a constant. Or if you want to think of it the other way, a times something raised to 2 times exponent plus b times something raised to the exponent equals c, meaning if this exponent was 6, this would be 12, or if this exponent was, let's say, 4, this would be 8. Okay, so this is one way that you can recognize equations that might fall under quadratic form. So what we'll do first, what's going to happen is when we recognize an equation is in quadratic form, we'll make a substitution to get it into a quadratic equation. We'll solve it, and then we'll substitute it back to solve for the original variable. But first, we'll just do some examples determining which ones of these examples are in quadratic form or not. Okay, so for example A, we have x to the 4th plus x squared plus 3. 4 divided by 2 is 2, or 2 times 2 is 4, so this one is in quadratic form. Example B, we have 3x squared plus, or 3x to the 6th plus 2x squared minus 5. If we divide 6 by 2, we would get 3. So this one would not be in quadratic form. Okay, and you'll see that as we do the examples and the substitutions, how these are working. Example C, we have 8 and 3. This is not in quadratic form. Example D, we have something squared plus something plus 6. If there's no exponent, you can assume it to be 1. And in this case, the base is x minus 1. So because of this 2 and 1, this is in quadratic form. Okay, example E, we have x plus 4 to the 4th, x plus 4 to the 2nd, minus 8. Again, 4 divided by 2 is 2, or 2 times 2 is 4. This one would be in quadratic form. And example F, x minus 3 to the 3rd plus 4 times x minus 3 to the 1st minus 2. 1 times 2 is not 3, so this one is not in quadratic form. Okay, so there's similarities there. And so we'll go over the process of solving equations in quadratic form, and then we'll do some examples. So we'll make a substitution first, and what we're doing is we're taking an equation that we've identified as in quadratic form. We'll make a substitution to get it in the form of au squared plus bu plus c equals 0. We'll solve for u using principles that we've learned, and then we'll make sure that we, in turn, solve for the original variable. So the first example, solve the equation x to the 4th minus 45x squared plus 324 equals 0. This is in quadratic form because we have power 4. Half of 4 is 2, or twice of 2 is 4. So in this case, we want it to be something like u squared minus 45u plus 324. Okay, this gives us what u is going to be equal to. U is equal to x squared. Okay, and you can see that too if you rewrite this equation as x squared squared minus 45x squared to the 1st plus 324 equals 0. If these were some other variable like u, we would have exactly a quadratic equation. So that's what we're doing here. Okay, it is important to identify what the substitution is. So now we have u squared minus 45u plus 320, I don't know why I wrote 25, 24 is equal to 0. So you can solve this by factoring, by the x method. Try one of those first before quadratic equation. So we'd be looking for two numbers that multiply to 324 and add to 45. Okay, so I'm going to write my factors of 324. And 9 times 36. Okay, so actually both of these would have to be negative in order to add to a negative and multiply to a positive. So my two numbers are negative 9 and negative 36. Okay, so again we have u squared minus 45u plus 324 equals 0. And we just found u minus 9 and u minus 36. Oops. Is equal to 0. So we can solve each of these equations for u. So we have u minus 9 equals 0, u minus 36 equals 0. Okay, solving for u, we add 9 to both sides. Okay, now our original instructions were to solve the equation, which means for the original variable x. We made the substitution that u is equal to x squared. So now in order to solve for x, we substitute u with x squared, and we have one more step. Okay, we take the square root of both sides. Remember, when you take the square root, we have the plus and the minus. Okay, and these are our 4 answers. And remember, when we have something being raised to the 4th power, we'd be looking for 4 answers, or something raised to the 2nd power, we'd be looking for 2 answers. Next, solve the equation. So we have t plus 4 squared minus 11t equals negative 30. So since we're dealing with quadratic form, we're applying principles of quadratic equation. We do want this to be set equal to 0 first. So we'd have t plus 4 squared minus 11t plus 4 plus 30 equals 0. And wouldn't it be really convenient if this was u squared minus 11u plus 30? Okay, so you can see that our substitution here is t plus 4. So at the end of this problem, we'll have to make sure that we've solved it for t. Okay, and this is equal to 0. So we're looking for two numbers that multiply to 30 and add to negative 11. That's u minus 6 times u minus 5 is equal to 0. And then we solve both of these for u, and we get u minus 6 equals 0, u minus 5 equals 0, so u equals 6 and u equals 5. And again, we made the substitution that u is equal to t plus 4. So now we have t plus 4 is equal to 6, t plus 4 is equal to 5. So we get t is equal to 2 and t is equal to 1. Those would be our 2 answers in this case. Okay, so kind of what I talked about at the beginning. If it looks like a duck, it might be a duck, or you can use the principles of quadratic equations to solve equations in quadratic form. First, the step is to identify that it's in quadratic form and then make a substitution to get it exactly to be a quadratic equation. Okay, let's go for a couple more. So we have x minus 4 times the square root of x equals 21. We haven't talked about this yet, and we'll solve it a little bit differently, but the square root of x is equal to x to the 1/2 power. So if we look at this, this power divided by 2 gives us 1/2, or 1/2 times 2 gives us 1. This one is in quadratic form, but like I said, we're going to do something a little bit different, where we are going to isolate the term with the root and be able to square both sides. Okay, so to do that, we will subtract x from both sides to get negative 4 times the square root of x is equal to 21 minus x. Okay, and now we square both sides. So this means negative 4 square root of x times negative 4 square root of x, and on the right hand side this means 21 minus x times 21 minus x. Okay, so on the left hand side, negative 4 times negative 4 is positive 16, and square root of x times square root of x is x. This is equal to, you would use FOIL on the right hand side, which we've had lots of practice with, so I'm going to go ahead and write it down. Okay, and then we want this to be set equal to 0, so we will subtract 16x from both sides. So we'll have 0 is equal to 441 minus 58x plus x squared. And we can write this so that our powers are descending. So we have x squared minus 58x plus 441 is equal to 0. Okay, so now we can try factoring. So I'm going to start writing out the factors of 441. So -1 times -441, and again, I'm using negatives because our two numbers need to multiply to a positive, but add to a negative. Okay, and then we have -3 times -147, and -9 times -440, or times 49. And if you're not sure what numbers go into this, you can use your calculator and just start dividing. So take 441, divide by 2, divide by 3, and so on and so forth. Okay, here's my pair. So now I have x minus 9, x minus 49 is equal to 0, and I get x is 9 and 49. Now something that happens here that we also saw, or that we'll also see when we're solving square root equations, is when you're squaring something, you could potentially be adding a solution called an extraneous solution, which means it's not really a solution. So whenever you square a square root to solve a problem, you always need to check both of your answers to make sure that one of them is the answer. So what that looks like is, first we're going to check x equals 9. So to do this, we plug it back into the original problem, which I'll write here. So we have 9 minus 4 times the square root of 9, and we want to know if this equals 21. This is 9 minus 4, the square root of 9 is 3, and this would be 9 minus 12. Okay, these are not equal. So 9, we would throw out the solution, okay, because it doesn't actually solve the problem. It's our extraneous solution. If we check x equals 49, we have 49 minus 4 times the square root of 49 is equal to 21. We have 49 minus 4 times 7, and we want to know if that's equal to 21. And if you put this in your calculator, you will get 21 equals 21. So our only answer here is 49, okay, or x equals 49. And the last example we'll go over, 5x to the fourth minus 17x squared minus 12. Again, this is in quadratic form, so we're able to make a substitution. Sometimes your substitution can come from this term right here, just depending on what we're working with. In the case of 5x to the fourth minus 17x squared minus 12, it would be really convenient if this was 5u squared minus 17u minus 12 equals 0. And again, that gives us the substitution of u equals x squared. Okay, so we can factor this. I'm going to use the x method, where we take 5 times -12, which gives us -60. Our middle term goes down below. So now we're looking for two numbers that multiply to -60 and add to -20, or -17. So it's -20 and 3. Okay, and now with this method, we take the number that's in front and we divide. So here we get -4 over 1. So this factor is u minus 4, and this factor is 5u plus 3. Okay, so we have, I'm going to go to the next slide. We have u minus 4 and 5u plus 3 is equal to 0. So we solve each of these for u. So u minus 4 equals 0, 5u plus 3 equals 0. Okay, so we add 4 to get u equals 4. We subtract 3. And we have our two answers for u, but we still have to make sure we do the substitution and solve for x. Okay, so I'm going to go to the next slide. Remember that u is equal to x squared. So now, oops, I guess I don't have room. Now we have x squared is equal to 4, and x squared is equal to -3 over 5. We can solve this using the square root property. So we take the square root of both sides, and don't forget the plus and minus. And for x squared equals -3 over 5, when we take the square root, we get x is equal to square root of -3 over 5 and -3 over 5. Okay, remember when we have a negative inside, it's the square root of -1 times the square root of 3 over 5. So I is going to show up here. We get I square root 3 over 5, -I square root 3 over 5. So I'm going to circle all of my answers in pink. Okay. So these are our 4 solutions. Thank you for watching. If you have any questions, please feel free to reach out to me.